Example 3 on rational root theorem. With rational root theorem, you can find the possible rational roots and also factor polynomials if you know a rational root. Little quick reminder that if you know your roots, you also know possible linear factors. So if x equals 3 is a root, then x minus 3 is a factor of the polynomial. If you have x equals negative 4 as a root, then you know x plus 4 is a linear factor. And if you have let me correct this quickly. So if you have a fraction root, then your factor, so if x equals 2/3 is a root, then x minus 2/3 is a factor. But in algebra, we don't like to have fractions, so it's really 3x minus 2 is a factor. These are the same. We prefer 3x minus 2. So if you have a root that's a fraction, write it as this right there. So if 2/3 is a root, write your factor as 3x minus 2. Write your factors without fractions, please. So let's go to the example. Using rational root theorem and synthetic division, we want to factor the polynomial and find the rational roots. So our polynomial is 15x to the third minus 32x squared plus 3x plus 2. So we want to find factors of p, plus or minus 1, plus or minus 2. We want to find factors of q. Factors of q are plus minus 1, plus minus 3, plus minus 5, plus minus 15. All our possible rational roots are in the form of plus minus p over q. So I wrote them out all over here. So I forgot to write plus or minus 1. Now the reason why I'm circling my plus minus 1, plus minus 2, those are the two possible roots I would check first. So we want to use guess and check to find the rational roots. And again, use the calculator. So we go to our calculator. We go to y equals. You enter in the polynomial, which I already did. You hit second trace. Enter. Now, the possible rational roots I want to check are 1 and 2. So let's do 1. We notice that 1 is not 0, so let's check negative 1. Negative 1 is not a root, so we can cancel this out. So let's check 2. 2 is a root, so we need to pull out that linear factor. I know 2 is a root because y equals 0 when x equals 2. So we know plus 2 is a root. So we're going to use synthetic division with x equals 2 is a root. That means x minus 2 is a factor. So if x equals 2, x minus 2 is a factor. Now we're going to use synthetic division. So let's use synthetic division with our coefficients of the original polynomial. So synthetic division with 2, and we're using 15, negative 32, 3, and 2. So we drop down, remember with synthetic division, our first coefficient, and we multiply. 2 times 15 is 30, and we add, we get negative 2. Multiply, we get negative 4. Here we get negative 1. Multiply, we get negative 2 and 0. If if this was not 0 for your remainder, that means you pulled out the wrong rational root. So if this was x to the third, this is x squared, and x, this is now x squared, x, and 1. So 15x squared minus 2x minus 1 is in parentheses. We know that x minus 2 is a linear factor. Let's factor again. Use box method. So use the box method. I'm not going to do it here. So you should know that when you factor using the box method, you will get 5x plus 1, 3x minus 1. Again, that breaks down. So we know x equals 2, x equals negative 1/5, and x equals 1/3. And those are the rational roots. Again, we can check with this that the rational roots, negative 1/5 and 1/3, negative 1/5 is right here, and the positive 1/3. So it would work either way. If you checked the positive 1/3 in synthetic division, you would still get the same factored form. If you have any questions, come see me after class or before school or during lunch.